Okay, so in this section of linear equations and rational equations, part one, we're going to solve linear equations in one variable. All right, so just review a couple of things from a previous course. Um, the definition of a linear equation. So a linear equation in one variable, x, and remember we talk about one variable, in this case x, is an equation that can be written in this form. So ax plus b equals 0. And keep in mind that a and b could be any real number, but a cannot equal 0. So this coefficient of x cannot equal 0. The constant here can be 0, but a cannot be 0. But in particular, the linear equation has this form: ax plus b equals 0. Notice the exponent of x is 1. All right, so if it was anything other than 1, like 2, 3, 4, anything like that, it would not be a linear equation anymore. So it has to be ax to the first power plus b equal 0. All right, now the other thing you learned in a previous course was how to solve a linear equation. So we're going to go through these steps in the first three examples. So remember, if you have any algebraic expressions, you want to simplify them on each side. So if you have parentheses or any grouping symbol, go ahead and remove them. Usually you would do that by the distributive property, and then you combine like terms. Then step two is you collect all variable terms on one side and all constants on the other. So you bring all variables to one side, constants to the other. And then three is to isolate the variable and solve. And then the fourth step, which if you have time on a worksheet you do, on a test you may not, but you always check your solution in the original equation to make sure it's correct. Okay, so and then we'll go over as we discuss this. We'll talk about all these terms here. Solving an equation, what does it mean? What's a solution? What are roots? Things like that. Okay, so the first example, let's look at this one. So the direction is going to say solve, and let's say we're looking at this one. We have number one, 3 times x minus 2 plus 7 equals 2 times x plus 5. All right, so I want to solve this equation. Now remember, to solve an equation, in this case it's an x, I want to find the value of x, or values. In this case it'll be 1, but as we go through the course, your equation, depending on the equation, can have more than 1. But to solve means to find the value of x that will make this side, when we substitute that value to x, this side will be equal to that side. That's what we're interested in. So that's what we mean by solving an equation. Now that number, whatever that number is, that's called the solution or root. Okay, solution or root. So just kind of review. So solve an equation in x involves determining all the values of x that result in a true statement when substituted into the equation. And then those values are called solutions or roots. Okay, so we're going to look at that as we go through this. All right, so remember the step one is to simplify the algebraic expression on each side. All right, so if you look at the left side of this equation, I have parentheses, I have grouping symbols, and then everything inside these parentheses you have to multiply by 3. So that's where we notice sometimes you'll use these arrows to indicate the distributive property. Notice I use the word the distributive property. And so every term in these parentheses is multiplied by 3. So 3 times x is 3x. 3 times a negative 2 is a negative 6, and then plus 7. Now, 7 is not being multiplied by 3, so don't make that mistake. So don't say that's 21. The only terms that are multiplied by 3 are the terms that are inside this parentheses. And so equal. And so here I have another grouping symbol. So I'm going to distribute, use the distributive property. And so 2 times x is 2x, and then 2 times 5 is 10. All right, so then still dealing with step 1. I'm still dealing with step 1. Step 1 says combine like terms. So on the left side, I can combine these constants. So a negative 6 and a positive 7 is a positive 1. So I get 3x plus 1 equals 2x plus 10. All right, now step 2 says you bring all the variables to one side, all the constants to the other, using our properties. properties of equality. So I'm going to bring the variables to the left. So in order to do that, remember I want to get rid of this 2x that's here. So if I add 2x to both sides, that's not going to help. I mean, mathematically it's correct, but it's not going to help me because 2x plus 2x is going to be 4x. So what I need to do is subtract 2x from both sides. Now remember, what you do to one side, you have to do the other, and only do it once on each side. Only do it once on each side. So, and then you combine like terms. So you'll be combining like terms quite often as we go through the process. So when I combine these like terms, 3x and a negative 2x is x, and then plus 1 equal 2x minus 2x is 0, and then equals 10. 0 plus 10 is 10. And now you bring all the constants to one side. So right now I'm adding 1. The opposite is to subtract 1. So when I subtract 1 and then combine like terms, I get x, that's 0 right here, positive 1, negative 1 is 0, x plus 0 is still x, equal 9. Alright, so that's what they call the proposed solution. So that's what I'm saying it is. But I could have messed up anywhere in here, so let's check it. Alright, so let's check this solution. Let's see if it's correct. So, remember I'm saying this is a solution. This is a solution to this equation. So if I substitute wherever I see the variable x, if I substitute this 9, then the left side should equal the right side. And always go back to the original because anywhere in here you could have messed up. Alright, so 3 times x, which is 9, subtract 2, plus 7, and I want to see if that's going to equal 2 times, and there's an x, and plug in 9, plus 5. Now let's just go ahead and use the order of operations since all these are numbers. So remember the order of operations in this case, remember please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Remember that. So I'm going to do parentheses first. So 9 subtract 2 is 7. So I get 3 times 7 plus 7 equal, and let's do this side, parentheses, 9 plus 5 is 14, so I get 2 times 14. Now on the left side, let's deal with the left side. On the left side I have, remember, multiplication, division, go from left to right, addition, subtraction, go from left to right. And you do multiplication before you do any addition or subtraction. You do multiplication, division before you do addition or subtraction. So here I have multiplication and addition. I got to do multiplication first because this says multiplication division has higher priority over addition and subtraction. 3 times 7 is 21. And I want to see, and then I'm going to add 21 plus 7 is 28 over here. Multiply these. 2 times 14 is 28, and they are equal. So this is a solution. So here's a solution. Okay. Number 2. Let's suppose we had 3 times x minus 4 times x minus 3 equal x plus 3 minus x minus 2. Alright, now, again, I want to solve the solution. So I want to find out what value of x will make this side equal to the right-hand side. So I'm going to follow those steps. The first step is to get rid of the parentheses. So I'm going to use the distributive property. So I'm going to do the distributive property here. I'm also going to do the distributive property here. And I'm also going to do the distributive property here. So I have 3 sets of parentheses. So I'm going to use the distributive property 3 times. Now this one's easy to deal with. 3 times x is 3x. 3 times negative 4 is negative 12. Okay, that part's easy. Now over here, remember subtraction in a previous course, if you had 7 subtract 8, remember that means 7 plus a negative 8. So you can always change subtraction to addition by adding the opposite. Remember, add opposite. Alright, so that was in a previous course, 3 courses ago probably. So 7 subtract 8 means 7 plus the opposite of 8, which is a negative 8, which becomes negative 1. Alright, so here, although when you read this you say 3 times x minus 4 subtract 4 times x minus 3, if you change it to addition, you're really adding a negative 4 times x minus 3. So basically, what I'm trying to say here is don't distribute the 4, you need to distribute the negative 4. So distribute the negative 4. So negative 4 is what you're going to distribute. So negative 4 times x is a negative 4x. Now be careful, a negative 4 times a negative 3 is, and remember, negative times a negative is a positive, so negative 4 times a negative 3 is a positive 12. Right, you learned all about these in previous courses. So a lot of this, almost all of this, should be reviewed from previous courses. These are prerequisites. Equal x plus 3. Now remember in the previous course, the idea of that coefficient, there's no coefficient there, it's understood to be a 1. So make sure you put a 1 there if you need to. That should be a 1. And so I'm going to distribute the negative 1, so I'm distributing a negative 1. So negative 1 times x is a negative x. A negative 1 times a negative 2. A negative times a negative is a positive, so I get positive 2. Alright, now, still dealing with this first step. I'm still dealing with that first step. So I remove the grouping symbols, and then now I'm going to combine like terms. So on the left-hand side, these terms I can combine. So these are like terms. So 3x and a negative 4x. Remember, you learned that the coefficient of this term is a negative 4, not a positive 4, a negative 4. So 3x and a negative 4x is a negative x, or negative 1x. But we tend to just write it as negative x. And then your constants, remember these are called constants, a negative 12 and a positive 12 is 0. So I don't even write that down. So don't just leave it as negative x. Don't say negative x plus 0 because that's still negative x. Okay, so that takes care of all these terms. And over here, on the right-hand side, I'm going to have equal. Okay, x, subtract x is 0. 3 plus 2 is 5. So I get negative x equal 5. Now, let me make sure. Okay, so now be a little bit careful. Remember, you're trying to solve for x. This is not x. This is negative x. So remember our terminology about the coefficients. If the coefficient's not there, it's understood to be a 1. So right here, let me rewrite this over. So right here, this is really a negative 1. So to get x by itself, a positive x, remember you want a positive x. Right now, multiplying by negative 1, the opposite of multiplying by negative 1 is to divide by negative 1. And now, negative 1 divided by negative 1 is 1. 1 times x is x, and that's what you wanted. So x equals 5 divided by negative 1 is a negative 5. So that's your solution. So assuming you did all this correctly, this is your solution. All right, let's look at number 3. All right, number 3, you have, let's suppose you had, I'm going to go ahead and make this one up. All right, suppose you had 4 times x minus 1 minus 3 times 2x plus 5 equal 2x minus 1 subtract 3x minus 4. All right. So let's just go. Remember, first step is to get rid of the parentheses, get rid of your grouping symbols. So we're going to use the distributive property. So I'm going to distribute the 4 here. 4 times x is 4x. 4 times the negative 1 is a negative 4. All right, here I'm going to distribute. Remember, you distribute the negative 3. So the negative 3. So negative 3 times 2x is a negative 6x. Negative 3 times a positive 5 is a negative 15. Equal. All right, over here, we're going to distribute the negative 1 over here. So distribute the negative 1. All right, so I get 2x, subtract 1. Negative 1 times 3x is a negative 3x. Negative 1 times a negative 4. Remember, negative times a negative. So negative 1 times a negative 4 is a positive 4. All right, and then I'm going to get 4x subtract 6x, we're combining like terms, is a negative 2x, and then a negative 4 and a negative 15 is a negative 19, equal. All right, over here, 2x subtract 3x is a negative x, and then a negative 1 and a positive 4 is a positive 3. Alright, now this step, remember the next step is to bring all variables to one side, constants to the other. So I'm going to bring the variables to the left. Now to do that, subtracting x is not going to help me. I'm hoping you see this, because a negative x and a negative x, they don't cancel. That's a negative 2x. So mathematically, I can subtract negative x on both sides. There's nothing wrong with that, because what you do to one side, you do to the other. But you want to make sure it's helping you to isolate the variable. So subtracting x from both sides is not going to help in that cause. So you're going to add x to both sides, because a negative 1 and a positive 1 is 0. So when you combine those like terms, that is 0. But what you do to one side, see how how I added x? Then you got to add x over here. If I add x here, I add x here. And now combine like terms, a negative 2x and a positive 1x is a negative x. Subtract 19 equal 3. And then bring the constants to the other. Right now I'm subtracting 19. The opposite is to add 19. And so a negative 19 to positive 19 is 0. So I get negative x equal 21. Oops, sorry, 22. All right, remember you're trying to get x by itself. So this is a negative 1x. Remember, negative 1. So to get x by itself, since I'm multiplying by negative 1, you're going to divide by negative 1. Divide both sides. And so negative 1 divided by negative 1 is 1. 1 times x is x. And 22 divided by negative 1 is a negative 22. All right, so that is part 1 of, let's see, that was part 1 where we solved linear equations in one variables. All right, now notice again, we use a distributive property to begin with. We talked about the definition of linear equation. We talked about the steps to solving a linear equation. We talked about these steps. We talked about what it means to solve a linear equation. And these solutions here, x equal negative 5, x equal 9, those are solutions, are roots. Another word for solution is roots to this equation, to the original equation. Okay, now one other thing I need to mention is this. So you need to understand that every time you go from one step to another, so I went from this equation to this equation to this equation to this equation to this equation, those are all equivalent equations. So hence the word equivalent equations. Equivalent equations have the same solution. So right here, equivalent equations are two more equations that have the same solution. So every time you do anything to each part here, as long as it's mathematically correct, then all these are equivalent equations, which means this. Remember how I plugged in 9 into this equation right here, and I got this side equal that side? Well, if I plug in 9 here, the same thing should be true. 3 times 9 is 27. 27 minus 6 is 21. 21 plus 7 is 28. See? And then here, 2 times 9 is 18. 18 plus 10 is 28. Whereas if I do it here, 3 times 9 is 21. 21 plus 1 is 28. 2 times 10 is 2 times 9 is 18. 18 plus 10 is 28. So this equation is equivalent to this equation is equivalent to that equation, and so on. So let's look at this equation. 9 plus 1 is 10, and 10 equals 10. And then here, this equation, so x equal 9, so 9 equal 9. So all these are equivalent to each other. So the point I'm making is this. Whenever you're solving equations, all this original, and this, and this, and this, and this, they're all equivalent to each other. So these are equivalent equations for this problem right here. So remember, equivalent equations are equations that have the same solution. So for this example here, for number 3, the original. So these are all equivalent equations. 1, let me do A. A, 4 times x minus 1 minus 3 times 2x plus 5 equals 2x minus 1 minus 3x minus 4. That equation is equivalent to this next step that we did. 4x minus 4. Remember how we got rid of the parentheses? Minus 6x minus 15 equal 2x minus 1 minus 3x plus 4. So A and B are equivalent. A, B, and C are equivalent. So when I combine like terms and I got negative 2x minus 19 equal negative x plus 3, those are all equivalent because when I plug in negative 22 in all of these, the left side is going to equal the right side. Left side equals the right side. Left side is going to equal the right side. And then D, when I went to this step right here, when I added x to both sides and I got this equation, they're all equivalent. So if I plug in negative 22 here, remember this means the opposite of negative 22. So the opposite of x, negative 22 is 22. 22 minus 19 is 3, and that's what you wanted. And then E, negative x equal 22. So if x is negative 22, the opposite of negative 22 is 22, and 22 equals 22. And then your final answer, x equal negative 22. So if I plug in 22 into x, negative 22 equals negative 22. So all of these are equivalent equations. So every time you do anything to each side of the equation, as long as it's mathematically correct, then all those equations you create are equivalent. All right, so that's all I want to do with part 1.